Hi, hello, welcome. In this video, we'll learn two sum lead code problem. So we'll understand the problem statement first. So there will be a given array of integers called nums, and there will be a target given, which is of integer type. So the output should be indices of two numbers, such that whenever it add up or sum up, so it should be equivalent to target. So it should be equivalent to target. And we can assume that safely we can assume that there will be an exactly only one solution within that array of integers which they have given it. So let's understand with an example. So they have nums array of integers they have given it, and there is a target. So we need to find out a pair such that whenever it sums up, so that should be equivalent to target. So here in this case, the zeroth place we have two, and the one index. So let's consider this all index 0, 1, 2, 3. These are all index. At the zeroth index, so 2 is the value. At the first place, there is a 7. So when we do a sum, so it will be equivalent to target, which is 9. So that's the reason we need to output the value 0 and 1. So this is an again array of indices. So this is the example which they have lead code has given us. So nums of 0 plus nums of 1, which is equals to 9. So that's the reason we are returning 0, comma 1. This is again the second example. So they give an array of integers 3, 2, 4, which is again 0, 1, 2, and the target they have given us a 6. So we need to figure out that pair of elements within this array which will sum up to 6. So in this case, the 2 plus 4 equals to 6. So that's the reason. So we should return 1, comma 2. So I think we understood the problem statement. Let's get into a solution phase. Now let's understand the naive approach. So in naive approach, the each and every element need to be compared with every other element. What do I mean by that? So let's say that 2 is the first element that need to be compared with all other elements. So for example, 2 plus 7 and 2 plus 11 and 2 plus 15. So this has to compare with 2 should compare with all other elements. So 2 plus 7 equals to 9. So we got a target. So here itself we can say 0, comma 1 we got it. But in other cases, so we need to compare each and every element to other element. So if this is not the case, if this is not having the element, then we need to compare with 2 plus 11. So again, this is not equal to target. 2 plus 15, this is also not equal to target. Then in that case, what we need to do is we need to increase this pointer, and it will come to a 7. And then 7 need to compare with all other elements. So 7 plus 11 and 7 plus 15. Again, this both are not equivalent to target. So that's the reason. So 11 again need to be compared with all other possible elements. So 11 plus 15 is the only possible pair. So that is not equivalent to target. So this is the way we need to compare each and every element to other element. So let's jump into code and let's understand how we can implement this logic in code. And this is a naive approach. This is not the best solution. We'll discuss the best solution in a minute. Okay, we are trying to implement the code in Java. So this will be our logic. So this will be our input. Let's understand what is the input. This is an array of integer, and the target will be given in for this method, and we need to return the indices in array form. So we are using for loop here, the outer for loop and inner for loop. I'm using the two for loops. The reason for using the for loop, simple for loop, is because I wanted to have control over the indices. That's the reason I'm using the for loop. This can't be achieved with for each loop, and it can be achieved with while loop, but while loop is quite complex to understand and to implement also. It's at least for me, it's tough to implement. That's the reason I'm going with for loop, simple for loop. So first, if you see, so the each and every element that will be the for outer for loop will point to a zeroth index, and then other elements which will be like starting from I plus 1, meaning the first index will be compared with zeroth index in a first go. Okay, let's understand this logic with an example. Let's say we have an array, 0th index, first, 2, third index. What we need to do is the 0th index need to be compared with all these elements, and the pointer will move to a first index, and the first index need to be compared with all these indices. And when this move to the second index, it only have the one option, that is it will compare with third indices. So this logic we need to implement with these for loops. So how do we understand this? Let's say the pointer is I here, and we are keeping the j pointer here. So we'll compare this I and j, and what we do is if it is not a target, then we'll increment this j, and again I will compare I and j. If the j is not again the target, you will increment this j. So I will compare again I and j. So this is the last element, because of that, so it will not proceed further. So it will go back to a outer loop. It will increment the I. So I will be, it will move to a first index, and j will be initialized to the second indices, and it will be, both will be compared, and then j will be incremented within this for loop, inner for loop. And once j is not matching the target, so this will be again one more outer for loop increment. So this will be again, it will move to second indices, and j will be here. So because j is already in last element, it will be have the comparison, and I will not move to a last element because I has to have one element to compare within other element. So that's the reason. So we are saying it will not move to the last, only the last second element it will move. So this is a logic to compare both I and the j. If it is equal to target, we are returning immediately the array of the indices. So now let's understand the time complexity with this. The time complexity will be big O of n square for this, because we are doing for each and every element need to visit every other element, and space complexity is constant. So can we do a better than this solution? Yes, of course we can do a better than this solution. Let's understand the solution. Okay, before going deeper into a code, let's understand one of the mathematical expression. If suppose a plus b equals to some target, and if we have a and if we have a target, to find out b, what we should do? So the expression will be b equals to target minus a. So this is what we wanted to try, because we have a target given, and we have one of the element. Whenever we visit any element right within that array, so we'll get that as a expression, and we wanted to figure out b element. So let's keep this in mind. So we'll use this expression in our logic. Okay, let's say we have an array and having element 2 3 7 1 4. So this is 0th index, 1 2 3 and 4. We have 5 elements. So we wanted to do better than big O of n square. So we can we achieve it in big O of n, meaning only one traversal of array would suffice? Yes, that would suffice. So the logic here is, so whenever we see a first element or any current element, so we'll do a target minus existing element. So meaning we'll do a target minus the current element. So in this case, target is 9 and the current is 2. So the whatever the element, whatever the value we are looking for is the 7. So if the 7 is available within this array, so then we have found another element of a pair. So we wanted to track down each and every element in a hash map or hash set, so that we can say that like, okay, this whatever the element is available or not. If this is available, and we will be returning the indices. So to do that, what we are doing is we are having a hash map. So this is of integer and integer of type. So this we will be storing the actual element of the array, and this is to maintain the indices, because the output should be the indices we need to return. Here we are iterating all the element one by one. What we are doing is we are fetching the value and we are figuring out what is the another pair which we are looking for, which is target minus value. So if that is already visited, which means it's already present in our array. So what we are doing is we are taking the current element, which we are iterating, and then the map dot get of key. So because at the whenever it's not found, we are storing the value and then the indices of that element. So we'll quickly iterate this array. So the first element will be 2. So we'll find the target minus value. So that is 9 minus 2, that equals to 7. So 7 is not already visited and it's not stored in this map. So that's the reason we'll come over and we'll store it in map. So that the map will have the 2 and indices is 0. And then it will go to a second element. The second element will be 3. So the 9 minus 3, the value is 6. So 6 is also not already present in the hash map. So that's the reason we'll come over here and we'll save it 3 and the indices is 1 and the next value will be 7. So what we do is 9 minus 7. So the value is 2. The targeted value or other pair of the other element of the pair should be 2. So in our case, so what this will return is true because we already have the element 2. We already visited that. So that's the reason we found this element. So when we found this element, so we are for sure we know that like there is a pair which is 2 plus 7 which is equals to 9. So then we'll return the current indices and the map dot get of key which is 0. So we'll return 2 comma 0 as a array and we'll return this value. So this is the time complexity will be because we are iterating only once array. So that's the reason time complexity will be big O of n. Here actually the space complexity will be big O of n because in a worst case we'll be saving all the element in this hash map. So that's the reason in a worst case it will be space complexity will be big O of n. But the time complexity we have done far better. But the space complexity in brute force solution it was a big O of 1 which is constant. But here it is the big O of n. So that's a trade-off than compared to a previous one. Whenever the interviewer says the time complexity is far more crucial than the space complexity, so we can say this is a better solution. But when the interviewer says the space complexity is a crucial thing, so probably the naive solution will be the better one here. Thanks for watching. Please hit like, share, subscribe. Thank you.